Good morning, Professor. Today I'm going to present the second topic in the mini project. My name is Pajanan Park Jariyanon. My topic is Smart PM 2.5 application that I choose from the third topic IoT platform. Let's talk about the application features. Firstly, it can check the PM 2.5 of the Bangkok area where things speak channel in real time. It is one of the most important air quality index which application update every 1 hour. Secondly, it can alert unhealthy level of PM2.5 to live user via live bot chat in real time. Thirdly, it can forecast next 7 days PM2.5 level and update to ThinkSpeak channel. And lastly, it can check the PM 2.5 at that moment or in the future time by command typing to live bot chat. Let's go to the overview of my application. I'm going to start at the application. This application is the Bangkok Air Pollution. Uh, this website has many air quality index, but I'm going to focus just only PM 2.5. And then this application connect with the Python, and Python will also connect with the MQTT and to send the real-time data of the PM2.5. I'm using the Python connect with the MQTT and then send it to the ThinkSpeak about the MATLAB. I get the record data for the last 3 years to forecast by the LSTM network and then send the 7 days for the 7 day data to the ThinkSpeak. About the line part, I use the Python to connect the line part. So Python will connect with the MQTT, which subscribe the ThinkSpeak channel and connect with the line user. It can do the alert or command typing. Let's go to the first feature. This picture is the interface of the website I already attached to you. This website will update the measurement result every 1 hour. And this website use the color to remind you what is the weather condition right now. I'm going to the inspect to try to find what ID is stored the PM2.5 in. So, and then I found that cur underscore PM25 store the PM2.5 data. As I mentioned you this picture, the number 80 is the level of PM2.5 at that time. So the 80 is the same number. That means this ID is store the PM2.5 data. I'm going to use the Python to fetch the data from the website and send it to ThinkSpeak channel. I create the on topic URL is the same website link that I mentioned you before, and then I use the beautiful soup to get the text data from HTML, and I create the value container to store the PM2.5 data and then connect with the ThinkSpeak by the client publish to update the data to the ThinkSpeak channel in the field 1. Okay, every time that I want to connect with the ThinkSpeak, I will use the MQTT broker as to connect. This is the result. At that time, the level of PM2.5 is 72 and it's updated to the field 1 of the ThinkSpeak channel. It is the same number. Okay, let's go to the second feature. Alert unhealthy level of PM2.5 to live user via live bot chat in the real time. Let me talk about the level of the PM2.5 first. Unhealthy level is the level that the PM2.5 value is greater or equal to 151. I'm going to connect the ThinkSpeak and Line with the MQTT broker. All of this process was produced by the Python. I'm create the Python code to connect the ThinkSpeak to Line. To subscribe the ThinkSpeak activity, any activity of the ThinkSpeak will subscribe to Line. Okay, after we already subscribe the ThinkSpeak, I will make the condition to alert the unhealthy level that in the red rectangular rectangle. If I do the condition if PM data is greater or equal to 150, is going to alert or send you the message to the live user that unhealthy PM2.5 level. Okay, this is the result that I told you before. Okay, we can see the unhealthy PM2.5 level alert you at 10:32. We can see the rectangle in the left side. At in the field 1, the number is 165. That is greater than 151. So the line going to alert you that it is unhealthy level. Okay, I'm going to the third feature, forecast next 7 days PM2.5. Firstly, I'm going to download the recording PM2.5 from the same link that I mentioned you before for the last 3 years in the Excel format, which the data is the average data in each day. This code is the MATLAB. About this code, I'm going to get read table to get the data, and my daily average data is I'm going to choose PM2.5 column and then make the standardized data and set the LSTM network to do the training. So choose the num hidden unit is 1000 and I use 2 layers of LSTM layers, and max epoch I set to 250 and then 10. Make a training. Don't forget to uh, create the info. This picture is the picture that I'm finished the training. Okay, and then I'm finished the training. I'm going to prediction to make the prediction of the 7 days, and then plot. Okay, I will show you uh, all of the 2 previous slides. This is the result. The red line is the predict, and the blue line is the observe or the real data. So it's not different. It's not going to quite different so much. So, but I use the training loss and training root mean square to to tell you how is my system going to be. So about the training loss is it to point so 0.0796 and training root mean square is 0.3991. And then I make a compare between the actual level value and predicted value in 7 days. The the up the upper the upper picture is the actual value and the bottom one is the predict value. So you can see it's not quite different so much. And then upload the predicted data to the TeamSpeak channel individually. I get the right key from the TeamSpeak channel, and ch_id is my private channel, and I create the week predict to store the 7 data of the prediction and then send it to the TeamSpeak channel. This is the result. Okay, this all of the data in the rectangular is the subscribe that show you what is the number in each field. So I use the second field to the 8th field to store 7 days prediction data. Let's go to the second field. The second field data is, just a moment. Second field the data is the 116, and the third field is the 122, and so on. We come to the last feature. We can check PM2.5 at that moment or in the future time by command typing to live bot chat. First of all, don't forget to fetch the data of predicted 7 days from the TeamSpeak channel first, and then make every variable as a global variable. For this tag, I use the day 1 for the first predict, and day 2, day 3, day 4, day 5, and day 7, so on. And then make it a global to use it in anywhere you want to use. Okay, I'm going to check the result. So for the command typing for PM2.5 at that moment, I'm going to type PM2.5 now. Okay, if the user do the command typing PM2.5 now, the system will reply back is the number of PM2.5 now. That reply you 165. Or you can see in the left rectangular in the field 1. Field 1 is the real time PM 2.5 that I mentioned to you in the first feature. Okay, for the command typing for PM 2.5 for forecasting, I create the sharp symbol for the special command to be the symbol of the prediction data. If you want to know the prediction data in the next Monday, we will use the sharp and Monday. Then the system will take you back what is the level PM 2.5 value in the next Monday, and so on. Okay, I'm going to show you. I'm trying to check the correcting of the system first. I'm type sharp Monday, and then the system reply me predict of PM 2.5 on Monday is this one, and Tuesday it reply this number, and Wednesday reply this number, Thursday, Friday, and so on. It is the same number that I show you that I'm already updated to ThinkSpeak channel. Okay, thank you very much for your attention. Our source code and data will attach in the same zip file that I will send to you. Thank you.